Hey, Matt Mathersum here with Matt Mathersum. Thank you so much for joining us and being a part of the program today. The critics appreciate it. My wife appreciates it. And I really do appreciate it as well. Seriously, thank you for joining us. Well, today we will be continuing with our partial fraction decomposition. This was the partial fraction decomposition that we dealt with the last time. And we said, well, what if we have to do the integration? Well, let me step over here. And this is what our integration will look like. We've got this integral of 2x over x plus 1 with x plus 3 dx. Now, this is a boundless one, so there's no limits, there's no bounds to this. So we're going to go ahead and just start with our x plus 1 or x plus 3 and get these out of the denominator. So we will be taking this is our a value, so we will say a in the natural log of x plus 1. And we've got our b value over here, which is b, in our natural log of, which is x plus 3. All right. I didn't put our sign in here because I don't know what that is yet. Obviously, I do know what it is, but we're going to act like we don't. Okay. Well, dealing with our a value, which is right here, because that's what we're solving for, right? Our a values and our b values, like we did over here, our a and our b. So what don't we want that x to be? Well, we don't want it to obviously be -1, right? So we will be covering that up, and I'll plug in -1 everywhere else I see a x, right? So -1 on top times a +2 gives me a -2 on top, yes. And if I plug in a -1 here, or -1 plus 3, that gives me gives me a +2. So a -2 divided by a +2 gives me a -1, correct. That is my a value. So let me go ahead and erase the a, because that's what we're trying to solve for. And I will just plug in a negative now, because there is a implied 1 in front of this natural log, isn't there? All right, let's go over here and head to our b value, which is the x plus 3 over here, isn't it? Yeah, so let's go ahead and see, what don't we want that x to be? Right, we don't want it to be a -3. So I will be covering up that, and I'll plug in -3 here in the top, and that's going to give us a -6, because -3 times 2 is a -6. And then if I plug in a -3 over here, what does that give me? A -3 plus 1 gives me a -2. Indeed it does. Well, let's see. A -6 divided by a -2 gives me a, yes sirree Bob, a +3. So now I can write my plus sign, and I can do away with the b variable, because now I know what it is. It's +3. And are we done? Oh, that we were. We have a indefinite integration here, so I've got to add what? The constant of integration, which is that. All right, I remember in the very first video that I said that I would be demonstrating why this actually works, and I'm going to do that right now. Let me just erase this, and we're going to make really quick work of this, because I feel it's really vital for you guys to see how this all shakes out. All right, so we're going to work with this particular equation again, since that's what we've been dealing with the whole time, and I'm going to see if I can fit it on the board here, because I'd like to keep all this together. All right, so let's go ahead and have our 2x minus 1 over our x, and we've got our x minus 1 multiplied by our x plus 2. And that is equal to a over x plus our b over x minus 1 plus our c over x plus 2. I think I probably have that right. X minus 1. Yeah, it looks like it is. Okay, I just restated this over here because we're going to demonstrate how this all shakes out together. All right, well, we're going to start with the x that's underneath the a, and you will probably be familiar with this if you know anything about partial fraction decomposition. I'm going to go ahead and multiply everything out by the x, and we're going to see exactly why this works the way that it does. So multiplying everything by x, I'm multiplying all the terms by x, and you're going to see why this is so powerful. Well, starting over here on the numerator on the left-hand side, you see my top x here and my bottom x here. Well, obviously, that'll cancel out. What does that leave us with? Well, that leaves us with this. It leaves us with 2x minus 1 over x minus 1, x plus 2, and that is equal to a plus b times x over x minus 1 plus our c times x over x plus 2. All right. Well, you can probably see where this is headed, right? If I take this value, which we said was 0, obviously, because we don't want it to be 0, but that's what it is, so that's why it's our value. If I plug that into here and I plug it into here, what happens? If I make this 0, this goes away, this goes away. I've isolated for A. Remember when I covered up on the left-hand side, I told you I'm isolating on the right-hand side and I'm canceling on the left-hand side? That's why, because now I've got A isolated by itself. The cover-up method allows us not to even have to go through these steps. I just demonstrated that these all collapse because of the value of 0. We isolate for A utilizing that cover-up method. That's the secret sauce. It isolates on the right and it cancels on the left. Very, very easy. Well, that's all the time we have for here on Math Madness. I'm your host, Matt Mathersum. I'm going to see you guys really soon.